So thanks Cisco and StarTree to invite us to speak at a conference and present our use case, what we did with Pinot. So I'll just walk you through. Can we go to the next slide? So we moved actually from ElasticSearch to Pinot for our user-facing analytics needs. So I have one more person from my team joining virtually. Unfortunately, he couldn't be here with us in person here. So I'm Shashank. I work as a director of engineering at the company, and my day-to-day basically is making sure that things are running smoothly. Development is being done, and I also contribute to a lot of code base in the team. So Rohit basically has been working with us as a data engineer, senior data engineer, and he has done a lot of good work on the Pinot side of things. So most of the Pinot related things, he'll definitely go and talk about it. So we can just move to what Beaconstack is. So Beaconstack is a phygital solution. Basically, we deal with a lot of QR code solutions. So what we do is we help companies track QR code analytics. So if assume like you are a consumer and you have deployed QR codes, you want to track metrics around it, who scanned it, where are the scans coming from, and analytics around it. Beaconstack is your tool for it. So we'll just move over to So there's a couple of use cases that we have just presented here. So specifically about Pinot, so we use Pinot for our real-time analytics engine and just to serve all the queries that our customers do for their data in the system. So you can, in terms of who uses us, so we have a lot of clients. So we have 30,000 plus customers, and from leading hotel chains in the US to Japanese OEM using Veganstack to deliver information about their car models and at showrooms. We have a couple of big brands in multinational like food chains who are using us to run their menus or run campaigns on ads on their in stores or on billboards and a lot of other places or on TVs. So that's what the use case for Beaconstack is. Oh, so we'll just skip with the demo for now. Yeah. If we get time, we'll just show you the dashboard as well. So previously, we actually were using ElasticSearch. It's a very similar story to what Babab actually showcased for Cisco. The only difference is, of course, Cisco is a very big organization that has a bunch of big amount of data. We being a startup, I'm going to give you some context about how we, as a startup, adopted Pinot, like in terms of scale and in terms of usage. So very quick high-level design. So we have our, so whenever you scan a QR code, it goes through a lot of data like pipelines and comes to our analytics processing servers. From there, it moves to data streams to data enrichment lambdas that are running on top of it, and it used to get delivered to Firehose, and then we have a backup that was being stored in S3, and the data was being pushed to Elasticsearch. And from the query side of things, so client APIs used to call the analytics servers, which are basically dedicated for fetching the analytics from Elasticsearch and presenting it in a visualization tool that the Beaconstack has. Okay, yeah. So I'm just going to talk about challenges. So specifically in taking Elasticsearch, we were running Elasticsearch for a while, and we were basically running into problems where we had to scale Elasticsearch again and again to every other 6 months, we had to scale up the systems to twice the size to meet our needs. And we'll just talk about what the amount of data that we were running since we have the last we migrated to Pinot was 20 nodes with a very vertical sailed system with 320 cores overall and almost a terabyte in memory. So that was the cluster size, and still with that cluster size, we are seeing huge latency on queries. So specifically, if you look at the, can we move to the next page? So if you look at the graphs here, so you can clearly see like the P95. Let's just forget about P99. P95 queries were around like 40 seconds or so. So these are like Elasticsearch queries that are being performed, and I'll just come to give you some other ideas on what exactly we were doing here as well. So we had a lot of timeouts that were going on with Elasticsearch, and very similar to Cisco's use case, where there are either high latency or things were timing out eventually. Can we move to the next slide, Suraj? So effectively, this was affecting user for our users itself. What used to happen, like people used to have to wait a lot of time to look at their analytics in the platform, and basically they used to get errors saying, hey, please retry fetching the data again and again, and this was causing a big problem for us from a standpoint of our usage and our customer base, for our customer base. So, and you can see the graph here. So you have like from some thousand errors to like 20,000 errors pile up on peak times on Elasticsearch. So can we move to the next slide? Yeah, so the other challenge with Elasticsearch being a very small engineering team, so we are a team of like 30 people or so. So we had a lot of challenges in making people learn Elasticsearch. So specifically when you go and try to hire people, for data engineering team, and you will not get a lot of people who are specifically well versed with Elasticsearch itself. So that was another like a sub challenge that we had with growing the team itself. And I'll give you one more insight about the errors that you were seeing. So we had built in on the application side of things, we had built in retry mechanisms, which used to on Elasticsearch errors, used to retry things, and would try to get the data by just retrying things a couple of times. So that used to cause us in a callback helper saying, hey, I failed in a 10-second query failed. It's going to run again for 10 seconds, which was causing a big problem from a scale standpoint. The QPS basically was very low on our Elasticsearch clusters. So effectively, we should have been able to serve around 100 plus QPS, but because of the high latencies and retry mechanism, we were in a situation we were serving around like 30 or 40 QPS overall. So I'll hand it over to Rohit to present the solution, what we work with.
Yeah, so thanks a lot, Shashank. Yeah, so the issues with the V1 system that Shashank had discussed got us back to the drawing board. We realized that a long-term fix involves moving the backend to an OLAP data store. And we started exploring our options that were available. And that's when we came to know about Apache Pinot. And let me just move to the next slide. So we decided to do POC with Apache Pinot for two reasons. One is a really good documentation, which gets you started with a minimum deployment in no time, and a vibrant Slack community. You could post a query and you get help from someone from the community itself. So we created an in-house multi-node Pinot cluster and ingested 1 year of data for experimentation purposes. The first iteration had no explicit indexing, and even with that, we saw better runtime than the existing system. So this acted like a green signal for us. This acted like a green signal for us so that we could spend more time and resources on the POC. Then there were subsequent iterations with different combinations of indexing on the different columns, and it was done in consultation with a StarTree team, and we saw massive improvements in the query runtime. The current prod cluster uses inverted index, range index, and StarTree index on various columns. We also did a comprehensive stress testing on the Pinot cluster. Moving to the next slide. Yeah, V2 system. Yeah. Yeah, so this is the high-level architecture of the V2 system. The green box that you see on your left side remains the same. It has the V1 engine. We have the Beaconstack analytics server, which pushes the events to a Kinesis data stream. And there is a data enrichment lambda attached to it, which does some transformation and pushes the data to the downstream Kinesis data. And that is ingested into. This is the real-time ingestion pipeline. We also have a legacy data ingestion. We have some legacy data. We use Apache Spark to process it and then write it out to S3. And then there is a minion file ingestion task, which ingests the data to the offline tables. This is a one-time ingestion task. Suraj, can you move to the next slide? Yeah. low latencies. As you can see in this graph, the latencies of the various queries is between 0.1, 0.5 and 1 second. And the P95 latency is less than 1 second, which is a massive improvement from the V1 system where the P95 was around 20 seconds latency comparison. So we saw 10x improvement in query performance, which translated to better end user experience. As you can see on the graph, the dark blue bars represents the Elasticsearch query runtime. For the 3 queries that we have on this graph, it took around between 10 to 15 seconds. And the light blue bar is the Apache Pinot with no indexing, and the query runtime has reduced to the max runtime is 6.3 seconds. And with indexing, it further reduced to less than a second. 0 errors. This graph is primarily the main reason for us to move to Pinot. As you can see, we haven't encountered any query runtime errors. As I've discussed in the beginning, we did a comprehensive stress testing on the POC cluster, and we were able to achieve we were able to support 100 concurrent users and 200 QPS with the median latency around 480 milliseconds.
Thanks, Rohit. So basically, from a cost standpoint, we saw like 50% reduction in number of nodes that we need to run to serve the current user base and the growing user base that we have. And we actually downscaled the each nodes to use less amount of computation power as well. So we had like 10x reduction in the number of cores that we are running. So effectively we were and 7x on the memory front as well. That's what we saved on by moving from Elasticsearch to Pinot. For specifically our use case, there are Elasticsearch was not becoming as scalable for us. And specifically on the cores front, we are also like to point out the amount of cores that we are currently at and the node size, that number of nodes that we are running. We are able to run many more concurrent queries for Pinot compared to what the same size of Elasticsearch clusters were running on. So yeah, that's basically from the cost reduction standpoint and the performance standpoint. So other benefits were observability became easier for us to, and we have like, of course, some managed solution over top of it, but observability became easier for us. The inception to Pinot for new engineers and people that you're hiring, or the current people who start working on the analytics engine has become easier with SQL-like queries over top of on Pinot compared to what we used to do on Elasticsearch. So basically in summary, what we did was we saw like almost 90% cost in reduction on infrastructure reduction, and like 90% reduction in P99 latencies over top of by moving from Elasticsearch to Pinot. And so we had, and apart from that, in the graph that you're seeing, actually there were no timeouts being shown there because they were not being captured at all. So we had like timeouts with queries running over 60 seconds for bigger amount of data as well. So there basically we had in the current systems we have 0 errors with the analytics engines. Thank you, everyone.